Hey students, how you doing? I hope you're having a awesome vacation, but if you're watching this on the day that I'm telling you to, it's Monday night, and it means we have to go back to school in the morning, which means we have to go back to work. So let's do it. Our lesson that we're going to be learning today is, I introduced this on the Tuesday before vacation. It was the introduction called Completing the Square. And I did one example in class on Monday. So these next three examples are actually just a repeat of that example I showed in class on Tuesday. I have an equation in standard form, and I need to rewrite this equation in vertex form. All right, so this is what we do. We start off by, I create a blank space. We're trying to create a perfect square trinomial, and I know that to create that perfect square trinomial, I'm going to need to add a number. And if you remember from in class on Tuesday, what the number that I ultimately decide to add, I'm also going to have to subtract that exact same number, so that in the end of the day, I'm actually just adding a 0, which means the equation is equivalent. So we learned on that last Tuesday that if you take this b term, which is 6, take the 6, divide it by 2, and square it, that gives us a 9. So that is the very number that we want to add here, a plus 9. And because we're going to add 9, that means we're going to subtract a 9. And because we did this x squared plus 6x plus 9, that works out to be a perfect square trinomial, which becomes x plus 3 quantity squared, and 21 minus 9 is 12, so you'd have this plus 12 on the outside. So f of x in vertex form would now be equal to x plus 3 squared plus 12. I guess just the one last thing is, some people have a hard time understanding how this thing became x plus 3 squared. But if we wrote out x plus 3 squared as x plus 3 times x plus 3, and you completely FOIL it, x squared plus 3x plus 3x, so plus 6x, and then 3 times 3 is 9. X squared plus 6x plus 9 is the same thing as x plus 3 times x plus 3, which is the same thing as x plus 3 quantity squared. So this entire thing became x plus 3 squared. Okay, same type problem number 2. Don't be bothered by the fact that this is a minus here. It's still going to work out the same way that they did previously. So I take the x squared minus the 8x. I'm going to need to add some blank. And then after that's this minus 12. And because I'm going to add this blank, I'm going to subtract that exact same blank. 8 divided by 2 is 4. And 4 squared is 16, which means that that's the number in these blanks. I'm going to add 16, subtract 16. This x squared minus 8x plus 16, that becomes x. Because this is a minus, I have a minus in my answer. And then square root of 16, or 8 divided by 2, that works out to be 4. So x minus 4 quantity squared, and then negative 12 minus 16 gets me a negative 28. And don't forget to include your g of x in your answer. So I've rewritten the equation in vertex form. Okay, if you understood examples 1 and 2, make sure you at least try these out on your own. Like if you haven't tried these out on your own, maybe pause the video, try it out on your own. I also have an example 3 here for you. Try this one out on your own, pause the video, try it out on your own, and then watch it and make sure that we get the same answer. Okay, here we go. So I'm going to show, this is kind of the pace that I usually solve these at. Let's see, so I have x squared plus 14x. 14 divided by 2 is 7. 7 squared is 49, so I have this plus 49. And then afterwards, I still have this negative 10. And because I added 49, I also need to subtract 49. X squared plus 14x plus 49, that becomes x plus 7 quantity squared. And negative 10 minus 49 is negative 59. And don't forget to include your h of x in your answer. And that's part one, when you need to rewrite your problem in vertex form. Part two. Part two is actually solving equations. Elliot's having butterfingers. Here we go. Solve by completing the square. So they give me a quadratic, and I need to solve it by completing the square. Okay. I'm going to set up the perfect square trinomial. Now, this is how it's different than part one. I take the 10 divided by 2, I get a 5, I square it, I get 25. That means if I want to set up a perfect square trinomial, I need to add 25. Now, because this is an actual equation, because I'm adding 25 to the left side, I can add 25 to the right side. This x squared plus 10x plus 25 becomes x plus 5 quantity squared. On the other side, 11 plus 25 is 36. I'm making a video lesson right now, so I actually need you to not talk. Sorry. All right, they're going to grab something. It's going to be kind of awkward, but they're going to do it. Do what you need to do, fellas. Let's see if they can do it without interrupting the camera. Anyway, go ahead. Yeah. All right. Good job, guys. Oh, that registration form, you got to turn that into the bookkeeper. Right now? Awesome. All right, guys, I got to continue on with this lesson because, you know, America, you know, they're watching. All right. Have a great holidays. You too. All right, see you guys later. All right. Sorry about the disruption. They don't know. Okay, so here, back to the problem. So we did the completing the square. We added the 25 to both sides. This factored to this. And now what do? We've got something squared equals 36. We square root both sides. And when we square root both sides, this becomes just plain old x plus 5. And then over here, because of the whole positive negative thing, you have to go both positive and negative 6, just like a normal one. We've done this before. Last step, I would subtract 5 from both sides. And positive 6 minus 5 is positive 1. And negative 6 minus 5 is negative 11. And those are my two answers. You will get two answers on these typically because they're x squared problems. All right. Same type problem, number 2, but if you understood how to do number 1, try out number 2 on your own and see if you get the same answer. And if you're unsure, do the problem with me, and then afterwards, do it on your own. Make sure you can do this problem either way. I take this 12, divide it by 2, and square it. That's 36. So I'm going to add 36 to this side, which means to this side I'm also going to add 36. This one isn't going to work out as nicely. It doesn't seem as the other one did. Anyway, this thing factors into x minus 6 quantity squared. This side, 4 plus 36 is 40. And when I square root both sides, I get x minus 6 equals positive negative square root 40. We need to simplify that square root 40. We've done this before. Let's see, 4. Square root of 4 times square root of 10, which becomes 2 root 10. So I have positive square root of 40 simplifies into 2 root 10. Over here, x minus 6. I add 6 to both sides, and I end up with 6, positive 6, plus or minus 2 root 10. Or if you want to write it the other way, I guess you could have written it as positive negative 2 root 10, and then you added 6 to both sides, so it would be plus 6. That would also be an acceptable answer. I'm actually surprised to see if this answer didn't work out pretty, but even if it doesn't, we have simplified roots in class, so you just need to simplify that root to get to your answer. And that is solving quadratics using completing the square. So anyway, that is that for this lesson. We have completing the square worksheet that we're going to work on this. And anyway, if you get stuck, don't be too concerned about this because we're actually going to spend 2 days working on completing the square worksheet before we get into harder completing the square worksheet problems. Anyway, I look forward to seeing you guys tomorrow, or right now if you're watching this video in class, say, hey Elliot. Anyway, hope you're having a good day and I'll talk to you later. Bye-bye.